bit of simplifying radicals. Remember last week on Friday we talked about radicals and finding a perfect square to divide out so we can simplify them. Because a lot of the year we're going to be having answers that have square roots in them, especially this next topic. And it is super important we are able to simplify them. Now, we simplified regular radicals, radicals with numbers out in the front, and we talked about how it's not okay to have radicals in the denominator. So this is the last bit of simplifying we have to talk about, and we call this rationalizing. So rationalizing is a fancy math word for removing the square root from the bottom of a fraction, from the denominator. So if we look right here, here's a perfect example start to finish. We start with a fraction, and in that fraction you can see we have a square root of 3 in the denominator. Okay? Even though the square root of 3 cannot be simplified, we can't divide it by any number in the left-hand column of that big long list, just because it's in the bottom means this is not okay. It's not simplified. We talked about it. It's like chewing with your mouth open. It's like bad math manners. So in order to get rid of this square root, we multiply the entire fraction, top and bottom, by whatever square root is in the bottom. So you can see we multiply by the square root of 3 over the square root of 3, which just means we're multiplying the top by square root of 3, and we're multiplying the bottom by the square root of 3. You can see right here, multiply, multiply. Now there's one little math rule we need to remember. When you have radicals, it's kind of similar to like terms. A square root of 3 and a square root of 3 are both square roots, so you can multiply those numbers. Square root of 3 times square root of 3 is the square root of 9, which is just 3. Now on the top, we have to be careful. 2 times the square root of 3 is not the square root of 6. We don't multiply those numbers because they're kind of not like terms. We can't multiply together a number without a root and a number with a root. So instead, it's kind of like, when we multiply 2 and x together, we just get 2x. Same thing, 2 times the square root of 3 is just 2 square root of 3. And you can see, by multiplying the bottom by the same square root, our square root is no longer in the bottom and we're done. So we've just basically rewrote our fraction as an equivalent fraction without any square root in the bottom. So that beginning and this end are exactly the same number. If you were to put those in your calculator, you get the same exact thing. So that's the idea. So if we look at number 1, we know this is a big no-no. It is no good because we have a square root of 5 in the denominator. There's a square root of 5 in the denominator, which means this is bad math manners. Whatever square root is in the bottom is what we want to multiply the top and the bottom by. So we would multiply by root 5 over root 5. On the top, when we multiply 4 and the square root of 5 together, I just get 4 square root 5. You're not allowed to multiply a normal number with a number in a root. On the bottom, however, because they're both in the square root, the square root of 5 times the square root of 5 is
1.
The square root of 5 times 5?
25.
Square root of 25, which makes a perfect square because we're multiplying a number by itself. The square root of 25 is just 5. So this would become 4 square root of 5 over 5. And we just check. I can't simplify 4/5. Square root of 5 can't be simplified. and I don't have a square root in the bottom anymore, so this is simplified. All done. We call that rationalizing. Number 2. What's wrong with number 2? Just like all of these, the denominator has a square root, which is no good. What am I going to multiply this by to get rid of the denominator? Square root of 7. So we multiply by square root of 7 over square root of 7. And now, just like before, what do I get when I multiply my top crossed? 2 times the square root of 7 is 2 square root of 7. Cannot multiply a normal number and a radical together. Just can't do it. Square root of 7 is the square root of 49, which makes a perfect square because we did a number times itself, and we know the square root of 49 is 7. Yeah, it brings us kind of back to the start, but without the square root. So 2 square root of 7 over 7. Can't simplify the fraction. Can't simplify the root because you can't divide 7 by any perfect squares. And there's no more square root in the bottom. That is a simplified radical. A little ugly, but it is simplified. Number 3. Now, number 3, I made a little bit trickier. And that's because, what can you tell me about the square root of 12? Is that a simplified square root? No, it's not. What perfect square can we divide 12 by? 4. It's in that list, that skinny sheet, that left column. We can divide 12 by 4. So we first want to simplify the square root before we start rationalizing. Okay, so when we simplify the square root of 12, we split it up into the square root of 4 times 3. The reason we're doing that is because we know the square root of 4. The square root of 4 is 2. So this becomes 5 over 2 times the square root of 3. And now the square root of 12 is simplified. Now whatever square root is in the denominator, in this case, it is a square root of 3. This is what we're going to multiply the top and the bottom by. We don't need to multiply by 2 square root of 3. We just multiply by the square root. So we multiply the top by the square root of 3, and we multiply the bottom times the square root of 3. And just like we did before, we multiply across the top, we multiply across the bottom. 5 times the square root of 3 is just 5 square root of 3. On the bottom, we have 2 times the square root of 3 times the square root of 3. So the only 2 things I can actually multiply together are the 2 square roots of 3. So I have 2 square root of 9. We good so far? Good? We know the square root of 9. We just multiply 3 and 3 together, so it's a perfect square. Square root of 9 is 3. So last thing we have, my board stops freaking out, 5 square root of 3 over 2 times 3. Because 9 just became a 3. So instead of 2 times the square root of 9, we just have 2 times 3. 5 square root of 3 over 6. 2 times 3 is 6. Again, I'm done because there's no square root in the bottom. The square root of 3 can't be simplified. And the fraction 5 over 6, if you were to math fraction enter, it would say 5/6. So our fraction is simplified. Now we're done. Right? I'm going to let you go ahead and try number 4 for a bit here. Before you start, square root of 8, is that a simplified square root? No. Simplify it first. What perfect square can you divide 8 by? Here's a perfect square cheat sheet. It's the largest perfect square. Let's split 8 into. That's the first thing to figure out. What perfect square can we divide 8 by?
4.
4. So we can rewrite 8 as 4 times 2. Which helps us a lot because the square root of 4 is on our perfect square list. The square root of 4 is just 2. So this just becomes 1 over 2 times the square root of 2. And now we know what to multiply the top and bottom by in order to rationalize it. We're going to multiply by square root of 2, square root of 2. Go ahead, multiply the tops, multiply the bottoms. When I multiply across the top, what do you get? 1 times the square root of 2 is? 1 square root of 2. You don't even really need the 2 with a 1. 2 square root of 2 times square root of 2 is? 2 square root of 4, which is good. We ended up with a perfect square, which should always happen. Square root of 4 is just 2. So I have 1 times the square root of 2, or just the square root of 2, over 2 times 2. Leaving us with our final answer, the square root of 2 over 4. And again, you always want to just quick mental note, square root of 2 can't be simplified. There's no square root in the bottom, so that's good. And if we were to remove the square root of 2, this would be the fraction 1/4, which if I put in my calculator and put math, enter, enter, 1/4 is a simplified fraction. So this follows all of our simplified rules, so we are done, and that is how we rationalize. So remember that this past week up until today, we have learned how to factor, we have learned how to simplify a radical, and we have learned how to rationalize a radical. Those 3 skills are necessary for what we start new this week. That is all.